In this video, I am going to brief you about UForm, which is a pocket-sized multimodal AI framework. UForm enables us to install and run smallest of the models on any device, including your mobile phones or any other devices. Even you can run these models on your Raspberry Pi. Now in this video I'm going to show you how can we install them and then how can we play around with them. And UForm is quite a comprehensive library which not only gives you the different models for text generation, for image manipulation, and also you can do some VQA or visual question answering from images. So you provide an image and then you can ask question about that image. I will drop the link to their GitHub repo too in video's description so that if you want to read further, you can. So let's get started. First, let's go to my terminal on my local system and then get it installed. So I'm using Ubuntu for this purpose, and let me quickly show you my Ubuntu version. So I'm using Ubuntu 22.04 and I have one GPU of 16 GB RAM. Let me clear my screen. In order to install UForm, all you need to do is to do this pip install UForm, and it is going to install the UForm on your local system like it is doing right now. And that's about it. UForm is installed. Also, there are few prerequisites which you need to install, including you need to have pip install pillow, torch, and Jinja too. So make sure you have them installed. I already have them, so I'm not going to install them again. Okay, having said that, now let me first show you the code as how you can use this in your code, and then we will review as about the similarity and cosine function of this model. Now this is a code which I'm going to use, and what I'm going to do here is I am going to give it this image of a kangaroo, and then I will first ask it what exactly this image is in a text, and then I will check the similarity through the embeddings. So if you go back to this code, what is happening here is that first we are importing the UForm, and then we are just giving it this model. Right now we are using V1 English. We can use another model for multiple languages. Let me also show you if I could as how to do the multi-language model. Now just give me a sec, I will go to my proper screen and then show you. So this is their GitHub repo. If you go down, this is, if you don't want to use English, then you can use this model for multilingual, but I'm just going to use with the English one. Okay, let's go back. Now in the next step, what is happening is that after downloading the model, I'm just importing some of the libraries from Pillow and from Torch, and then this is the text I'm using, a kangaroo hopping, and then the image which I just showed you, I'm opening that image with this. Then I'm pre-processing image data and text data which I have just specified here, and then I am creating embeddings on top of it with the help of this model UForm v1, and then I'm checking the similarity between it, and from there I'm also checking the joint embedding. Now to search for similar embeddings, the embedding can be compared using cosine similarity as we are doing here. The resulting value will fall within the range of -1 to 1, where 1 indicates a high likelihood of a match. Once a list of nearest neighbors or best matches is obtained, the joint multimodal embedding created from both text and image features can be used to better re-rank or reorder the list. The model can calculate a matching score, which we are printing here, that falls within the range of 0 to 1. If it is 1 or closer to 1, it means that a high likelihood of a match. So you can see that images of the kangaroo, and we are exactly specifying what is happening that in image. So let's see what is the similarity between this text and images. So if the score is 1 or closer to 1, then it means that this model is correctly identifying it. So let me run it. Let me go back to my terminal and let me run check form, and I'm using Python just on my local terminal. You can use git bash or whatever you want. Now let's run it. So it is going to download the model first time, and there you go. So the value is around 0.9965, so which is almost 1. So amazing stuff. So it means that model has correctly identified it. Let me change that to the text to something else, like I'll say maybe I'll just call it a chair. That's it. Let's see what happens now. It shouldn't be similar, and it should be 0 or closer to 0. Let me run that again. There you go. So you can see it is way off. So it means that this model is working, which is amazing. And now let's do some of the question answering from the image itself. So let me show you another piece of code where I'm using this. So if you look at this code, what is happening is that I am importing some of the causal LM and VLM processor from the UForm, Pillow, Torch, and then I am using this model in this processor for a Unum Cloud and Unum Cloud UForm gen in order to do the question answering from this image. And then I am just asking it that summarize the visual content of the image, and then I'm passing it kangaroo.jpg. And then you can also ask these other questions if you just paste them here. And then I'm passing this to processor with all the hyperparameters with the torch, and then I am decoding the text and printing it. So let me run it. Let me take you to my terminal. Let me clear my screen. Check image.py. Okay, sorry, I have not py, it is Python 3. This always trumps me. Okay, let me run it. There you go. It has downloaded the charts, and let's see what happens here. There you go. So it has correctly told you that a kangaroo is flying through the air, its legs spread wide in a desert-like environment with a blue sky in the backdrop. So if you go back to the browser and check that image again, there you go. So one thing I would say, its legs are not spread wide. Maybe it has mistakenly, or maybe these are the legs. Anyway, I will. Okay. So, but still, backdrop is sky. This is a desert-like environment, fairly close. I mean, if you look at the size of this model, which is just, I would say, a UForm, 143 meg or something like that, then this is amazing. The quality of the responses is amazing. And another thing is that you can port it to Apple's Core ML or even on ONNX for cross-platform. And also there are a lot of other good features around it, that they have only used 256 dimension vectors, and by doing that they have made it 2 to 3 times quicker than from the clip models, which is amazing. And inference is also around 2 to 4 times faster. And so this is it, guys. I hope that you enjoyed it. If you're stuck or if you are struggling to implement it, let me know and I'll be happy to help out. Just paste it in the comment. And of course, if you like the content, please consider subscribing to the channel. Thank you very much.